All right. I hope you have worked on the first part of this chapter. The second part is more of a calculations. The first thing you need to know is how to work between stoichiometry and heat of reaction, because you're supposed to work on thermochemical equations that include chemical reactions and heat of reactions. How to deal with them? You are normally given the mass of a substance, whether it's reactant or product. Then you will use its molar mass to change it to moles. Then use the heat of reaction to change it to kilojoules of heat. Let's work on an example to make it more clear. Again, the same example of burning sulfur in the air. You burn 15 grams of sulfur in the air. How much heat is evolved for this amount of sulfur? Here's the thermochemical equation. You have it per mole. The delta H is per mole. You calculate it, remember? So you always start with a given value, and the same here. 15 grams of sulfur, 1 mole is 256.5, and you know that for 1 mole you have 2.39 times 10 to the third kilojoules of heat evolved. When you do this calculation, Q is going to be minus 1.4 times 10 to the second kilojoules, means this amount of heat is released. So you basically have similar questions for the relation between stoichiometry and heat of reaction, because this delta H is given for 1 mole, and sometimes you have a sample, you don't know how many moles it is. So you need to relate it to molar heat of 1 mole and calculate the amount of heat which is released by that particular sample given to you. All right, in the next part, you need to know how to measure heat of reaction. You will be working on an experiment. It's called thermochemistry lab, and you will be working with this formula, and you will be using styrofoam cups as calorimeters. What is a calorimeter? Is a device, I told you styrofoam cup, as simple as styrofoam cups together to trap the heat, do a reaction, and measure the heat of that reaction. So let's work on the formula. Q, which is heat, is ms delta T. So Q is heat, and its unit is in joules or calorie. M is the mass of substance in grams. S is the specific heat in joules per gram degree Celsius or calorie per gram degree Celsius. And delta T is temperature change in degrees Celsius. Delta, delta sign means change. It shows change, right? So, what is a specific heat, which we show in S, is the amount of heat which is required to raise the temperature of a substance by 1 degrees Celsius. Or we are missing something here, of 1 gram of substance instead of, change it please. So the amount of heat which is required to raise the temperature of only 1 gram of substance by 1 degree Celsius or 1 Kelvin is called a specific heat. How do we know what's the unit for specific heat? Is Q over M delta T, right? It's joule per gram degree Celsius or calorie per gram degree Celsius. You can also rearrange this formula. Instead of M times S, you have another term which is called heat capacity. We show it in C. So C is M times S. What is heat capacity? Is the amount of the amount of heat which is required to raise the temperature of a given amount of substance by 1 degree Celsius or 1 Kelvin. So specific heat is for only 1 gram heat capacity for any given amount of substance. So you can modify this formula based on what is given to you in the questions. Time to work on an example. A piece of zinc weighing 35.8 grams was heated from 20 degrees Celsius to 28 degrees Celsius. How much heat was required? By knowing that specific heat of zinc is 0.388 joules per gram degree Celsius. Of course, the amount of specific heat is always given to you if you need it. So Q is ms delta T. What was mass? The given mass is 35.8 grams. Specific heat is given 0.388 joules per gram degree Celsius. What is the temperature change? Temperature changes from 20 degrees Celsius to 28 degrees Celsius. So that temperature change is 28 minus 20, which is 8. Calculate it, and with 3 significant figures that you need, you round it off to 111 joules. That's the amount of heat is needed to raise the temperature of zinc, this much of zinc, for 8 degrees Celsius. All right. The last part of this chapter and this discussion is about how to calculate the heat of a reaction. You have 2 methods, let's say 2 ways to do it. One way is to use this